Because I was running animation times in class, and I walked right back out.
Alright, if you guys like to use dry erase markers, you can get those materials. If you would rather use paper, I also have pictures and papers for you guys to write on. Alright, let's talk about the goals. You have them, you see them there? Everybody sees them? Alright, so I'm not even gonna lie to you guys, like when I go to little group activities and I get placed in a random group and they assign rules, sometimes I don't really enjoy that so much, but this is meant to help and create intergroup reliability so that you basically aren't just people sitting near each other, you actually need each other, okay? So the reporter is the only person who can answer questions for the group. So if I come over to the group and say, how's your group doing, the reporter would tell me. Or if I say, how did you get that number, the reporter would tell me. So the reporter is a spokesperson for your group, so they need to know what you're doing, right? But of course, obviously, everybody should know what you're doing. All right, the recorder is the person who's going to type into the Desmos and ultimately write up your final answers. But again, everybody needs to contribute to that. Following me? So you got to make sure you agree with what your recorder is writing. You want your recorder writing about your stuff you don't know where it's coming from. All right, the facilitator I think of as the parent of the group. Because as a parent, you need to be firm and keep people in line, but at the same time, you need to be nurturing and is everybody ready to move on? Or do you all know where these numbers are coming from? Or is everybody's voice being heard? Everybody being able to contribute in some way? So facilitator, you have to be a pretty mature person. I hope that's not an issue for anybody. All right, the questioner. This is sort of a cool idea here. So the questioner is the only one who's allowed to ask questions of me, or the questioner can go over to another group and ask that group questions. You follow me? So if your group's seriously stuck, and you're asking questions of me, I might say, you know what, questioner, go over to that group and ask their reporter how they overcome that obstacle. Okay. Honestly, my goal, the big goal is all the ideas are going to come from you guys. I don't want you over-reliant on me. I want you guys to feel confident in what you're doing. And there's going to be moments of shakiness, that's okay. But I want you to convince yourself, of the logic or lack thereof of what you're trying to do, okay? So we'll pause at times throughout the activity and I'll have people share out what they did, big ideas that are moving us forward as a group. So we're not all hopelessly stuck or whatever. Okay, so go ahead on to slide 2 then and see what you guys can come up with as a group. Okay, so what strategies you think will be useful there?
So that way you have a radius is halfway more.
Or
Yeah. So that way you know that half of this is what the altitude is.
oh yeah.
Does that make sense?
Weird. I have an idea.
And then you can figure out what the angles are because all they do is want you to
Talking about the radius is 1. A, B, C, all edges.
Alright.
Well, 14 is not an angle though. Okay, so sine, so here's what you're mixing up angles and your sides, you're looking for an angle. You take the sine of the angle. So the sine of the angle.
So this line is a diagonal. From this point. And these two will be diagonals, just 2 times the radius because diagonals.
Oh, yeah.
Even with all these ones.
Yeah, from the edge. Yeah, and then every angle
I put the lines up there as well, it's just so that the numbers.
Okay, so then we can do.
Is equal like all equal sides?
Yeah, so we define height.
Oh, so you're going to have it is 60, 60. That's 30. So that if these are here.
So we know that that.
Alright, I think I'm all just gonna work out.
Two.
You guys are gonna do it. I'm involved for sorry.
So we can find this using sign.
Alright, so since sorry, because since you said equal laterals and the radius is 8.5, it's just gonna be 30, 30, 30, 30, 30. Since we have taken these, I think for 120. Since we have one is radius, 1 all the way up to 5. Sorry, I go. It doesn't need to be perfect. Look at this monstrosity I had from the
I guess.
Well, especially with stuff we didn't learn yet. I tried doing the last question.
And then, what's left? Recorder, who's typing these? So you might.
I said, recorder. I'm noticing that you all are writing on steps or you're sharing. Just make sure you're all sharing each other's ideas as well. I
got one.
Make sure you guys have ideas.
Yeah.
And I see a whole bunch of different ideas. So
Wait,
just
collaborate.
make sure they all get shared at some point.
What's the point?
Keep going, guys.
So, yeah, I don't know.
The triangle, no, the triangle ABC is the equilateral. This triangle
So,
right
we
here
know that
is
that.
that part. So what you had was probably wrong. So yeah, what is what you got the square root of 30? Yeah, so you don't even write it on there. So that's 1.7.
So, do we need to have that?
Oh wait, no, and then
So then,
wait.
click on that and remember, hey, you're all
And then if it's, hang on. If it's equilateral, then everything is 1.722.
Because the rate is
The bottom of that triangle is the bottom of that triangle.
No, are we figuring out the closure of the circle or the one?
Yeah, alright, yes, yeah, perimeter is
That's why I
average,
remember.
right?
I remember an area on the circle that mattered.
But the perimeter is average, right?
So it's at 0.866. And then Saturday's one.
Who's facilitating?
It's still 1.7.
This many times then divided by that. And that's how much.
Because anybody at all, anybody, the height was when I was starting
Okay.
site, they don't have it okay, right? So make sure you all present the strategy.
Perimeter, or 5.196.
Okay, do you have strategies that you all understand? No. It's kind of area and perimeter.
I don't think so. Well, there's not, like.
So if you want to find the area. The area is,
We need to find
it's base.
and then we can just do, so now since we know this, we can find,
Times one half. So
we can find, inside the
now
so
that-
it's all, and then equal out triangle, just
I'm just gonna redraw mine because we don't have.
We have
Found one
this.
thing, so-
then they have the angles.
Absolutely.
So now we can find the limit.
So what did you find?
Yeah.
Then you
Okay.
the length of that whole thing.
Yeah.
So then.
So usually, so you just like do that all.
Oh, so, yeah.
To discuss how,
Alright.
like all lean into it, like put a picture and see if you can make sense of how you
This is the
use that
area.
information, because like you said, all
This,
you have is that
this is
equal out
two
triangle and
of
radius
the
is
spot
one.
triangle.
One of those two things combined to let you unravel this
So how do we
whole.
find?
Is this the same thing that was only this?
So you got two different
You
pictures
just
down
add it up,
there.
right?
I think that you have
So
a
it would
really
be-
good
that's a
solid
really
foundation.
good-
We're not judging here. We're trying to figure out what happened. You just.
So how does that explain to me so that I can make sure I know? Perimeter being 6. And the area. See, I have to make sure I broke it up before I can make everyone else.
Supposed to be there. Like how the area is
So it's about area for a triangle.
Well, I can get
So.
I'm getting close to where
That's
it is.
what I did.
They get it,
This was.
So that next would be what?
What?
Home facilitator.
So I'm
Well, the height that you get.
Okay, fine, I'm the reporter, I can't.
It's not judging. I'm just saying, I see independent work done around here.
What height are you doing?
As long as they're in
The entire
that
triangle.
all that you come up
Oh,
with.
I broke it up.
I tried
That's why I
this,
did.
So it would be
and this
sine.
seems to.
Okay.
I tried this and I got stuck. Right?
But anyway,
So it's bad.
So the height,
Yeah.
so the height is
You guys need to
1.5.
come together and see what you all have to share.
So-
What's going on.
Height's 1.5. Base actually is 1.7, so.
I mean, I guess it could make it.
So what's,
Are you taking?
radius is one, right? So when you're pointing this, where,
I think you did that.
where is the?
The area of the whole triangle.
We did the same thing, except I used the entire triangle.
It's time to have one make two.
What's the definition of radius?
What, okay, now my question is, why did you times by?
Are there any radii drawn in your picture?
There's three diameters.
I'm gonna tell you.
All right, okay, yeah. Okay, so, yes,
I don't wanna say too much, but
One-
what's the definition of a radius?
You get a color?
yeah, we got the front earlier, 95.1. And another group.
So we need to know what a radius is.
6 for further.
So if you want to go ahead and go over the radiuses or whatever, but there are radii in your picture. You know how long the back are.
Yeah, we get the same answer 2 different ways, so I've seen really good ways.
You have the-
I feel like you really played that, I'm sorry.
Yeah, that's not your job.
Yes, I'm gonna go make mine.
So this, she hasn't unlocked them all, this is, we're still, take it out of the
It's the same throughout every of that, some form of chocolate.
So if you can figure out where the top ones go.
Yeah, I trained it, so like anywhere from the Okay. So if you want
Yeah, it's all seems small, right? Okay, so.
I got one.
The radius of the circle. So all this is our
Well, you can't really tell.
Well, that's the line that we use. But if you were to cut it half, it was well,
Yeah.
each side.
They have a co-op. They have a
Since
co-op.
I know the radius.
The radius is one, that's given to the radius. If I tell you the radius of a circle is 1,
I think, no, I think even if you have to.
what does that mean? So you know where to put this 1 in your
I'm
picture,
pretty sure.
okay? So,
I know a lot of people that are in and they're just trying to catch up on child work.
yes, that would be, please.
I don't know if it's.
Like shop, like
So do you have any?
Like your shop is like DMS or something.
We're at it.
Okay, so that would be 1.
And more circle, it's like
Honestly,
Mine's in there, it goes represent you.
I do. No.
So because we're all triangles, you're all 60.
Okay, I got that.
Like what should do is she should like magic or
That, it's not.
Oh.
Either, you don't know what they're gonna
She,
Okay, should be the center to the
So it's
same.
a
like,
right
you remember how like explaining the shop should be, or you get graded by the shop teachers?
And you know that.
She gave me a bad,
percentage.
she gave me a bad grade, so I had to ask her questions.
All right, we're gonna pause and share out some big ideas right now. Go ahead, talk, finish up your thought. I'll give you like 30 seconds to clear it.
Okay, so.
Okay, while they're finishing up their little conversations, I want everybody to appreciate that there are multiple approaches to this. So when we share out and somebody does it away differently than you did, do not think you did it incorrectly, okay? Right, so that's my bad. So don't erase your work in the future. I take some pictures of it and stuff and Dr. Carl. Okay, but you know your strategy in general. Okay, all right, so I saw people draw this in School of G. The pictures are pretty similar. What's the benefit of doing this? So can somebody share with me, what would be the benefit of drawing these lines in? Logan?
The one on the left, the blue lines represent the radius, so that way you get a side that you know the length of, which is 1.
Okay, so did y'all hear that? Does that make sense to you? All right, so those blue lines are all radii, and they're all equal to 1. Okay, great. All right, so can someone share a next step for them that you think was maybe a helpful breakthrough? Or Ariana, what did your group come up with?
So since we knew that the radius was 1, we just went ahead and we like cut the triangle in half so that then we could like, and we also knew all the angles because it's an equilateral triangle and all has equal 1 angle. So we knew every angle was 60 and we cut the triangle in half and then we could basically find each individual side in both triangles.
Do you mind come up and label the angles up there, please? For us, not for us. Minus Wilson's room. Now, is it not gonna write? Is it gonna do that?
Oh, it's gonna do that instead.
No, it should let me write it. Something not cranking. All right, never mind. Do me a favor, can you draw it on your picture? On your,
That's gonna be really hard.
yeah.
There's a board right there. Just use the board that's right next to it.
All right, just, you know what? The smart board decided the pens aren't gonna write, so I'm glad we have video of this. Do me if she's gonna try to draw it on her picture and see if I can get it. Worst case scenario. There she is. Okay. Is that this one?
Yeah.
All right. What do we think about these numbers?
Where do they come from? What do they do?
So since the radius is 1, and like, if you can see like the bottom half of the triangle, it stretches all the way across the circle. So we know that like half of that would be the radius. So since the radius is 1, we need it that side. The other side is also 1, making it 2. And since the equilateral triangle, every side would be the same.
The bottom isn't fully stretching the width of the circle.
Say it again, Logan.
The bottom isn't stretching the full width of the circle, it's just stretching from different parts of it. If it was the full width, it would actually be the diameter, which would be, or the line that would have to, the middle of the line would have to touch the middle of the circle in order for it to be diameter.
Do you agree with that, or do you understand what he's saying there? Anybody add on to that, or paraphrase what he said, or? Okay, so what side lengths do we know?
The blue lines, the 1, 1, and 1.
Okay, so we know the blue lines are 1, 1, and 1. And I'm not trying to diss your drawing at all. I don't want you to feel that way at all. Okay, let's see what we got here. We're going. So we know. And this is how normally most people start out the problem. In my experience, is they draw vertical and horizontal. They know that these are all 1. But now we know also that these orange lines are 1. We all agreeing with this? Okay. Okay, so then here's the angles that Mariana started talking about. All right, is that enough for you guys to start figuring out what the perimeter and the area are?
Slightly.
Okay, so, again, multiple ways of doing this. And honestly, my goal here is to share out as many different strategies as we can. So, Emma, could you share out some approach that you don't have to get, like, just talk to us in broad terms. We noticed this and that we could use this strategy typically.
So to get the perimeter, we took like a little triangle. So you see how there's like 3 triangles.
Okay, could you come up and point to us, it's like this little triangle here. It sort of sucks at the Okay, so show it to everybody though, stay up there. Charles, it's all good.
So then we know this is 120. Oh,
We can write on it that way. It wouldn't let you, yeah, that's all good.
Undo arrow, there's the back arrow.
sorry.
Now you can just write with your finger on it.
Okay, so this is 120. And then this is 30. Yeah, 30 and then 30 right. Okay.
It's not gonna let you write it, but hey, it is. Good.
So then we did cosine of this, 120. And we got 1.7 something.
7, 3.
Yeah, 1 point, sorry, I erased all my work. 7.3. And then,
Okay, so stop for a second, and stand back so we can be sure each of you can see what you're doing.
sorry.
All right, so everybody, are we clear where the 120 came from? Do we need clarification on that? Can we share where the 120 came from?
Okay, because this is a triangle, and we know, okay, so we know that these are all 60. So we divided by 2 because it's being split in half. So then we can determine these are both 30. And then because a triangle has the angle of 180, we subtracted 30 and 30 got, again, we got 120.
Does that clear things up for people? All right, so that top angle of that orange triangle is 120.
Yeah. This one is.
All right, so then the other ones are 120 as well, is what
Yeah.
you're saying?
So then we took 1.73 and we times that by 3.
Whatever,
5.196.
whatever 1.73 times 3.
Yeah.
Okay, can you share again where the 1.73, what strategy did you guys use to get the 1.73?
Cosine.
Law of cosine.
Law of cosine.
Because we have this angle. And then, you want me to show you that?
And the 2 sides.
All right, what do you guys think about that? Okay, did anybody, thank you, Emma. Did
Okay.
anybody do it a different way?
I just have a question. How do you know that angle B and C are perfectly split in half to 30 degrees?
Because the radius,
And equilateral triangle.
since it's since B and C are right on the edge of the circle, the radius can go straight through it and cut it evenly in half.
Okay, so that's a great question, right? Because we talked a lot about how we can't assume anything just because it's split in two doesn't mean it's split in half. Okay, so the symmetry here is really important. The fact that it's a perfectly symmetric triangle. That if you did split it, it is going to get split into two equal parts. Is there another way, though? Is there another way that you could justify that that top angle is 120?
You can make a circle with the three triangles that we have there.
So let's look at this one. Let's expand it. Go ahead up there and show us what you're thinking now in the folders. So I don't want it to be just the one group, but let's see right there.
This work? You just make a circle there and then since circles 360, 120, 120, 120.
Who heard that? Can somebody restate or rephrase or add on to what he said there? Carmona, can you clarify what he just said there? Say it a little louder, that's my daddy. All right, did you guys hear that over there, Emily? Could somebody else want to add on to that, or clarify, or rephrase, or restate what? Why did he draw that circle in the middle there? What's the purpose of that? All right, they're all the same angles, right? Those three triangles are all the same triangle. All right, and so what else, Marissa, add on to that? So he draws that circle. Well, how's that helpful? That's what I'm trying to get at.
It's always helpful to know more information.
Right. So what information does that provide?
All the angles, I don't think so.
All the angles have to come together and make a circle. Or how many degrees are in a circle?
360.
Okay, so I don't know if that prior knowledge came through for you guys or not. All right, Molly, does that make sense to you guys? Okay, so what was the purpose of having him do that is that sort of reinforces Antonio's question of, can we prove that this is 120 another way? Okay, so 120, 120, 120, that would add up to 360. All right, that's 120, then we can split the difference. All right, so we can get this side using law of cosines. All right. What else do we know? So between Emma and Ariana, we also were able to tell that these were 30-degree angles. Okay, so right now I want everybody in your groups to think, are there any other strategies that are useful that we could use to find this side length? Just try to brainstorm some other strategies that you might like just as well or better. Or maybe you don't like them as well at all, but try to come up with another idea. Just have a conversation. Don't have to write anything down, just,
I want you to show us.
okay, well,
We're getting there.
I wasn't prepared.
Oh, your area, if you want to share your idea for area, that's there's going to be a lot of big details now.
I think it's just.
I mean, I understand where you're going with that, but I know a lot of people in here are getting confused about that.
I have to take all this. Or you have to do it with all of these.
Well, which is probably something different because you do one out there. Classes and teachers do.
And I thought it was recording,
Oh, that's why you painted it.
No, I just panicked because I didn't remember how to do it. And then I remembered it was recording.
You're not, listen, not recording for years. Just to teacher.
any other thoughts? So I drew that on to the side there. I don't know, since you want my control on this. All right, so that's a good question, huh? Why do we have this, what's the purpose of having this triangle in a circle? What information, why is that useful, like, or? Alright, so that allows us to know, yeah, say that again, Marcy, please.
Each line is the same as the line.
So that allows us to know, these blue lines are all the same, they're all radii. So the radius of the circle ends up helping us, right?
Yeah, radii is.
Okay, so, say that again?
Once you like know that,
Yeah, once you know those lines are the same, you can pretty much ignore the circle, yeah. I mean, and so if the circle is just getting in your way. But if you didn't know how big the circle was, you know, you wouldn't know that. All right, so what other strategies came out that you could use to find that third side besides using the law of cosines? Law of cosines will work perfectly. Anybody try something different? Logan?
Let's exploding and make it a right triangle.
All right, so we could split that guy and make a right triangle. If we have a right triangle, a whole bunch of strategies should come out that we could use for a right triangle. Could we leave it as a not right triangle? So I just don't want to give too much away. I'm just trying to plant seeds in here. Could we leave this not a right triangle and solve it using anything? Sabrina, you have an idea? Say that loudly. Could we use law of sines here?
Yeah.
All right, so somebody who hasn't spoken yet, tell me, why could we use law of sines on this dude? How would you use law of sines? All right, guys, be brief, throw ideas out there. I'm going to try to get some more people involved. Sabrina, go ahead, tell me, how would you use law of sines? Tell us, I should say.
each side of the line corresponding to one side.
Wait, stop, hold on. I can't hear her. I want to make sure everybody's listening to her. Say that again.
Each side of the line corresponding to one side is the x, one side of 124 is 1 and the same, 30 was upon each side, that side was 1
You got the exact same answer on this one. All right, did you hear her explanation for law of sines?
Can she repeat it? I didn't hear it.
Thanks. Thanks.
I did x divided by sine of 120 equals 1 divided by sine of 30, sine 30, and then multiplied each side by sine of 120. Thank you.
All right, so we can use law of sines. Okay, then Logan pointed this out, and I don't want to say too much more than this, but he said, why not do this? All right, so we could do law of sines, we could do law of cosines. Law of cosines we'd already said, law of sines, Sabrina suggested. All right, and then Logan throws out, well, why not just split it up into right triangles? All right, and then that gives a whole another realm of possibilities. Okay, whichever strategy you use, the third side of the triangle is 1.73. Okay, so just so you can check that you are getting correct answers, but the strategies are, to me, what's the most useful. All right, so now we have one side, and we know it's an equilateral triangle. We're good. We can find the perimeter. How do we find the area? So Emma can't wait to share how she found the area. Talk to us.
Okay, can I go there?
You can go up here. You want to write on the board. You want to write on that board. You can write on whatever board you want to write on.
Here we go.
For this side, we already know this is 1.73 for all of this. And then I divided by that by 2 to get this area, this length. And I got 0.86 or something like that. And then I did, I found out this height by doing law of sine. Wait, no, something's out, sorry. So I did sine of 30 over 1 and then x. X equals. Which is 0.5. So then I did 0.86 times 0.5.
0.43. Go ahead.
What do you mean?
I'm just doing 0.86 times 0.54. You get 0.5.
Oh.
Right. Sorry, my bad, I need to shut up.
That's okay.
No.
All right, so think out loud for us. What's
What do you mean
sort
we
of,
confused you?
No.
it's all good. Just
You did
tell us
this
what
way.
you're thinking as you're thinking it, because we'll learn from it.
Okay, so originally, I did this. So I found out the area of that, and that would be both sides, technically, and then I times that by 3.
Why don't you just do 1/2 times cosine, so you have both of them?
What I do?
Oh, I think
Do you think you can add on, Ariana?
she's basically calculating them both together, and then all she has to do after that is multiply by 3 to get the whole triangle.
She's getting the area of an individual one, and multiplying by 3 to get.
But I got different than that because I used the exact numbers and I didn't use the exact.
Okay,
So
all
that's
right, so instead of rounding. All right, so we're more interested in honestly your strategy than like, oh, what was the 14th decimal place of your answer? But although, obviously the answer is important. So go ahead, Ariane, what do you want to add on?
I have a question. So since she did that with the bottom portion of the triangle, if she did it with the whole triangle basically, wouldn't that just be, she would just have the two sides that she needed so she could find the area of the whole triangle without, like, creating a square around the whole, like, around the halves basically, so then she has both.
All right, so you gotta pose this question to the whole class. So you're saying find the whole big triangle.
So she made a like a square around one half, right? So like, could you do it around the 1/2 of the whole triangle and basically have the whole triangle after you multiply it by 2, or after you have that?
Can you go up and maybe draw or something? I just make sure. I don't want to
Like
answer
this
your
whole
question
thing?
if I'm not sure.
Yeah, because
What I was thinking.
like you did like this, and then you had like the area of that. You did like this, and then like right, and then you had the area of both put together because it's basically 2 right now.
Yeah.
Couldn't we do it like around the whole triangle, like this? And then once you find that, you would have the whole thing.
Yeah, I guess you
Here, I know what you're trying to.
I don't know.
And I want this, like I said, I want the conversation to be led by you guys. So if everybody needs to be tuned into the conversation, and you guys up there, you tuned into what she's saying? So what do you guys think? I need you to be able to, if you have questions about what Ariana or Emma are saying, ask them.
I can draw this right.
You want to draw?
But if you know that every side is 1.73, then why don't you take the 0.86, that's your base, and then you do so because you already have the AB, and then you know B and half the C, so then you can get the height, and then do 1/2 times base times height.
Yeah, I think that's what Ariana was saying, but like, I just didn't think of that. This is what.
All right, so of the utmost importance to us here is the understanding that you can do that, like that you can do it so many different ways. So many different ways. Like I need you to understand that creativity is like a great thing to have here. I know you want to show Logan, I promise I will let you. I use this analogy all the time, you probably get sick of hearing it, but you know, how many different ways are there to build a house, right? You have all the tools to build a house, and not everybody is going to go about building their house the exact same way, but you all end up with like a nice house when you're done. Same thing here, we're trying to find the area of this. So, to me is saying, I just want to use this, just straight up use this formula. I don't know why you guys are drawing squares and stuff, but then you're like, no, but I see it this way, and now you know, this triangle is half of this triangle, why don't I just find both of them all at the same time by making it into a rectangle? As long as we can appreciate that we're accomplishing the same goal, we're good. I need you to understand each other's strategies. And you know what I really like so far, guys, is that this desire to want to understand each other's strategies. I don't want it to just be, I just want the answer. I want to understand your strategies, how you got them. All right, so do we feel like, Logan, we're going to let Logan give, he feels like he can clarify some of the loose ends here.
Is there if I erase some up there, because I'll be open up.
Or can you, since you're tall, can you maybe right above it?
We'll see what happens.
Okay, do your best.
Alright, so I'm just gonna draw the triangle on that circle, just to see some there.
All right, everybody listen to him.
That's the right triangle. Then we know that the length of this was 1.732 millimeter. So then we're just trying to find x that's right here, the length of the height. And it's just going back to just sine 60 equals, or we get opposite over hypotenuse. X divided by 1.732, and then multiply both sides by this. And x equals
1.5, it's 1.5, I can tell you. I did that calculation.
Oh, no, yeah.
They'll save you
Yeah,
trouble.
I forgot, yeah. So the height of it is 1.5. And then the base of it was 1.732. So, or because this is an equilateral, each side is the same length. So since this is 1.732, this is also 1.732. So, and then we just have to times it by 1/2 or 0.5. That gives us, that gives us 1.29.
So, questions. So you could do the whole big triangle as a whole, find the whole height of the whole big triangle, which Logan just demonstrated, or you could do the individual triangles. Right? We got this as a strategy? Right, and we're using everything we've ever learned so far. All right, thank you guys. Okay, let me ask this question. I didn't mean to do all that. If we use this triangle here, and we find the area of that triangle, which is what Emma was doing, okay, how do we use that to find the area of the whole triangle?
It's 1/3 of the area of the whole triangle. It's 1/3.
Do you guys agree with that statement? All right, so that orange piece and this purple piece and this green piece, what's the relationship between those?
They're all in the same area.
All right, so that's an important thing to come out to. All right, so we got skills, they're multiplying, and we can do all kinds of stuff. All right, good job. All right, so.
Oh,
I want you guys to go ahead and go through slide 6. 3 and 4, take a couple minutes, ponder some things, but do not spend more than a couple minutes on slides 3 and 4, okay? Just throw some ideas around. Make sure that your computer's in such a spot that everybody can read it. And I'm going to pass out some papers. It's like,
You know if that one, I'm confused.
It has five.
Can we get this in English?
I think it's a shame.
a polygon, many sides, polygons,
So that you don't.
So a triangle is a polygon with 3 sides, right? A square is a polygon with 4 sides. A pentagon is a polygon with 5 sides. Okay, so a polygon has many sides.
Oh my God.
So 4
She
is
just went out there.
I think the area.
This is a law.
I think that on the sides, it really, like there were more sides. That's what I'm sure there is. Oh,
I'm
yeah.
also gonna add
Angle, you have to do the first
Touching more than every class. Probably, yeah, because find out more of the.
Oh, what is this?
Would the perimeter get
So
bigger?
it's just so you can add more sides and see and experiment. Make sure everybody can see it.
The area would definitely get bigger.
Sliding, add more sides or fewer sides, just so you can
Is
test
it,
your
is
theories.
the perimeter the same way though? No, the perimeter can't move if the area is not right? I don't know. Yeah.
Shape, no matter how many lines we draw.
I don't think they're
And the
able
perimeter all the way?
Is that your hypothesis?
So I'm worried.
Like we can, word inside is defined.
Choose a piece.
So you think that turtle area should be the same as it was for the triangle?
I meant like the area of the square was.
I'm gonna say.
Yeah, you can break it up into 100 pieces, but they would all add up to the same. Okay.
I'm sure what this question
That one,
The question's asking here, when you start adding more
Squares is
sides
all
to the
done.
Oh, so you
polygon.
get different shape.
Yeah,
Okay.
so it went from having 3 sides, and it's 4 sides, 5 sides, 6 sides, 8 sides, whatever. What happens in here?
Do you want to do square
Okay,
and
and
all
then,
do pentagon?
And then it just says,
But what am I
what size about that? So
Just
just
find the
And
area in the
then
perimeter of the
it's
square.
gonna ask you to pick 2 of those.
Oh, I think the area of calculation for square
Start
is different
to
than.
come up with a strategy that you're like, you can give me any polygon. I got it.
Wait, is an area the same side, not polygon?
Give me-
I forget what it is for square.
Okay, so pick any 2 you want. There's a couple on the back. You know.
I'm pretty sure that's what I'm getting with.
Wait, do we get
I
any?
know for perimeter stays the same.
You click on 6 up there.
I know.
Yeah, no, we don't get any sides, but you have angles.
The area change for the square.
Yeah, but then.
Yeah, you can make the square triangle.
So both, basically both.
I can do that.
They make it a right line.
Do it all. Do it all. So we don't need sides.
Okay, so the radius is still 1. Okay, the radius of the circle is remaining 1. Is everybody okay with that? You hear what I say?
What do you mean I have the easier way?
We should all be like doing it, like throwing ideas out there together. It's like for hours, we're not minding yours for hours.
that just make this 45?
I just put water.
Okay, this thing looks like complete and utter garbage, but
What's the question?
Remember to see if I can see good strategies. In the first class, I actually used pictures of people's stuff because there's so many.
Brady eye is still one. Brady eye.
Everybody drew on
All the Brady eyes.
You have the answer to all. You know you should, you know you do.
unless four other
Big.
now they made it but he turned to the little group because they had a question.
So we find the area for one of them, times earlier, all we have to do is find, this big deal that does
Wait, and if you are, like, why are you like sharing out there?
So you're doing law science,
Just a
right?
tad.
You sure, like,
Individually, just trying to take things out.
yeah, but you have ideas.
We're all talking to each other.
You share my.
Aren't the radius always one?
I don't know. I'm trying to. All right, I can go ahead. Let me get my ruler. They're just more,
It said,
Well, I say that now, it's like.
this is just, I don't know. It was an easy This is just so you can fill it inside.
So if I dump this class,
See, like, maybe guess what happens. Just add more sides to see.
I like how
there is. That's how I got.
You wanna try mine?
Okay, so you're gonna have to do it.
That is what.
That's because I brought them.
Slide 6. Slide 6. Just 2.
Like on the first day.
yeah, it's a square.
I already told her that.
Oh, dang, now I
Try some stuff out. I was like,
Now I got your versus graph.
I did.
Connections to the conversations that we just had.
What
about it, Marissa? You can see a little.
Did you retake
Okay, so.
See if you can connect this idea.
So that's the like one side to the.
Oh, boy.
1.41 times
Look at how long it is.
There you can. There you can, because it goes straight
So like how do you
Again, multiple ways to do that.
But you put them all in half, so.
What's our status over here?
Angles. 45 is the
Check.
So how do you know?
This is
just showing
So,
you.
is it a right angle or something? Right, does this make a right angle?
Yes, if you turn it this way.
Oh, okay.
So then you still would turn it on one side.
Yeah.
Do you have people in that?
Where is an N, like N is the number of
I
sides.
mean, 4.
I saw it.
So you go out like different sides. This.
You have some examples here. The one with eyes on the side, the end of connected to what we were doing, area perimeter. Now, my dad is strategy that
Just find it one of the triangles.
but I don't have it.
Would you mind individually adding this one to be like Robin? Oh, no.
I would actually have these research triangles. That's 3 papers.
So we know this is, if I'm like,
Where's the number three triangle?
yeah, because it's either that way, then it's right triangle. So it would be like, just a joke.
Perimeter and
What?
triangle.
So these are all two, let's look at my.
I like triangles.
It's not like that.
You don't have to find area.
I said we were doing the background. We only know two of them. I'm doing
Yeah, there's two that's the same as one.
Because it's easier than doing a Pentagon.
Yeah, so it's the same as
Wait, how are all these? Yeah, like, so the reason this is right, I'm asking, how are all just like, it's like, if it's right, it's like,
not all sides of the triangle, the hypotenuse of the triangle.
but if you, even if you look right here, it's 1 on 1, and then this is 1. So every,
That's one.
yeah, but that's why you have, I think you have 1.41.
Yeah. Because you just
Wait, but no, the radius is 1. You want to put this one as the radius, right? So it's, so this is just 1. So, but, and then this is just 1, because that's also the
Yeah, everything from the edge.
But how is it all these are the same? Like, you have to write on the
Yeah.
How are they all?
Wait till you try to do the Pentagon one. Oh my god.
I've already looked at how it's supposed to go.
Trying to work out the confusion.
This was.
That's 2 different things.
So, this is what you guys saw on the square, actually. What about, I know, I'm just,
Alright, so squares are nice because everything is right triangles.
because all these things are to be.
That's what I was trying. The longest side.
Yeah, I think these are all regular patterns.
And then a square too. It's 1.4.
Yeah, that's what I said. That's what I said. I needed that.
Oh no, that was just when you did the traffic jam.
Yeah, that's good. Here, I'll take a picture of it too.
Hold on. What am I looking at?
So now we need this.
Nope. You guys want to see the formula?
Just make.
I have that song.
So then you have fun.
Where is
We are just gonna want to.
What even is? I hate it.
What's gonna happen? And then we'll do like that. No, there's another one.
Remember, it's checking
And that's
No, lower than.
Length times width equals. So yeah.
So, okay, so you don't even have to find. You don't have to find. So,
Times itself. So each is times the perimeter.
Okay, so we know that the area is 2, but the triangle place, like 1 times 1 is 2, right, so how do you do that?
And then this is all.
Times perimeter.
Length.
Okay, I got you. So you just do 1.4 triangles?
Alright, so now you're throwing in a whole nother, strategy.
Why is it called double
I don't write it.
Yeah, you actually use it.
Isn't that area?
Here's
I thought we were trying to find.
That's a double,
Since
that's a double
it's,
thing.
since it's the same, all the length and width is the same. If we were doing a rectangle, then it would be.
Okay.
Yeah,
But
what
like,
was,
so we can add it,
what was the area of the
Very
square?
good practice with the square, it seems like you're on the road to something.
I got.
Yeah.
So if we were doing,
Keep working hard now.
so all you have to do is 1 times minus 5, the area, or
The area,
0.5 times
yeah.
2.8, kind of area. I was trying to look at it, so you didn't want to do that.
Alright, so.
The formula says
Wait, well, but these are triangles that I saw.
yeah, you don't have to.
We created it.
That's
So why did we do it first?
No, but the thing is that, because the thing with the signatures is, there's a reason why they have you write your digits right before you even do something. Because they can't read cursive.
My mom said.
So yeah, no, so certain people, like doctors do on a prescription, you like write it like this or something like that, and then just write your name in print.
You know when you pay with like a credit card and stuff, you can use it for like.
You're having a good conversation.
Oh, my mom.
Yeah, they don't care, they don't check that.
Just 1.4 times 2. I love it.
Yeah.
My parents, when they do that, they just do this.
You're right.
More size guys, you guys on all this
What
stuff.
I used to do in.
I mean, it's hard.
45 everywhere. More. Equals the length of the triangle. That really is.
For number 5? Wait.
The 5 side.
Wait.
This is a hypothesis,
We
it
should do it
has to
like,
be bigger than
we should do it like this, right?
I feel like writing J about it.
Yeah, that's what I'm saying. 5 triangles. But then this way.
You want to see what a Z is? I had to figure out how to do, I had to figure out how to do it.
Wouldn't it be, are those like, wouldn't it be easier?
We had to learn it and so many kids struggle with it. Like we had to write a whole like 3 paragraphs. We had to write a whole like 3 paragraphs or something in cursive. Yeah, everybody was struggling out with it. Yeah, I had to do that in like 5th or 6th grade. Everybody
we
was
all-
still struggling with that.
Yeah, log cosines do have a C.
I think I did learn that. It's just, I just didn't.
We found out,
We don't know if we
now you're gonna get it.
So we have to use log.
How do you
Define the other, okay, I got you.
Define how the large.
Yeah, these teachers are the same way I do, and I don't bother simplifying. Alright, so that's finding this angle, and then finding this side. Yeah, that's good.
So either have to break
Times 6.51.
Okay.
Oh, yeah, you know Roger's class?
I put the whole number down.
What do you mean 6.9?
Because we know since the center of the circle is the angle of 360.
We went from signatures to infinite.
Then we can do log cosine, sine, the side, the
Look at
Nothing yet that I know of.
Okay.
enjoy yourself?
I mean, we're just writing the names of the rest because we're waiting.
Are you finished?
What am I supposed to do?
Okay, so, if you're finished, it's like, just so that.
Well, now is the time.
Shared with
The area of the time.
No, it's
Then you
true.
can multiply by.
No,
This one? Stop over here.
yeah, we can.
Yeah,
so.
They figured out the idea of error, this.
No, it's true.
So I said I was sine 45 equals
It's okay.
y over x. And for some reason I.
So now all we have to do is do, wait,
Remember that?
and so we're gonna fix it?
Yeah, I got it.
Oh, I know what you're talking about,
I
yeah.
like this, so it's like 30 and this would be 60. Smart, right?
Yeah, you like make a triangle with it?
Is this is
No, it's the time.
Oh, like you
Yeah,
do.
like, you know, this is.
That's why I was-
Wait, no, it's the right time. Yeah, so that's why we're asking.
Alright, so sine of 45.
So you're trying to find that.
My calculator is definitely.
The height, so you can find the area.
Sine of 45 equals 1.
Yeah, so
My
like.
calculator is so
Okay,
good.
how do you subtract?
Ten.
That's
Opposite
on the bottom, so how?
Yeah, opposite of the. That's
What is,
So,
what is in this?
so I'm trying to tell what those colors.
You got 1 point.
I have your problem.
For one.
No, it's not, it's not to put it in a certain. It's not just to put it, it means it's actually a symbol, not the shape.
No, like, she gets a different person every time.
What are you doing? What's exactly you're doing? You're not 100% sure.
So,
Oh, yeah, no,
trying to get the
it's
terms
zero.
of the side bar. So I'm going to so the sine
I don't
45
know.
equals y over x. And so after that, multiply side by x squared.
Where's the green?
X times sine 45 equals 1. We're going to divide the side by sine 45. And you're going to divide 1 by 8.
What do you do? What ends up being the same? So what do you end up with the, what's the calculation you're doing?
That seems right. So we use triangles to find.
So make sure, he's doing the same thing that I did when I showed you.
It just makes sense.
You can combine.
So I was right.
So what you
So
get?
multiply each side by x. Since x on the bottom, x on x.
Alright guys, it's 11:01. I'm gonna need us in about a minute to come together so we can, just throw some strategies out, some things that you're starting, just little aha moments that you're maybe having, and go from there. So if you're in the middle of calculating something, but I do want us to get some ideas out there.
So, yeah, we need to
Yeah.
keep the area.
Okay, so here's what I decided in the last class is I said you're gonna put together like a rough draft of your, whatever for Schoology, and then tomorrow I have to give them a survey anyway about just reading it, and then I'll start out with them revisiting the rough draft. And then, after, people just share out ideas, and then revisit your rough draft, revise it, and then take the survey. And
It's too rushed now.
yeah, right, but I do need it to be done well.
Oh!
I got it.
Yeah. It's a pretty, and my random grouping didn't work out perfectly. Where some of them gave people fall under the
I see.
and some of them.
Oh, this one more.
So, I'm looking over at this and realizing you start to draw stuff and now you're like, maybe not. Can we, you want to make a connection there? A 3-sided one and 4-sided one, that we apply to the 5-sided one?
Check it out.
But I write in all the letters. So, I write in a lot of the lowercase letters,
Let's see if I know what the triangle line Okay, so this is the connection I'm trying to promote without.
Well, we're gonna continue that way.
But this is how we drew in. Hold on.
Okay, B and D.
I just didn't think in a circle.
Wait a minute.
What are all the same size? The radius. So if you're drawing lines in that aren't radii, you don't know how long those lines are. The only lines that you know for sure the length of is the radii, the ones that radiate from the center. So ask Molly what she thinks about that. And that's the center, that's the definition of radius. Okay, so you know that's one. So for example, if I look at the line that you sort of draw from A to C, yeah, you can do a triangle there, but I don't know how long that is. The only sides I'm sure of the length of. So take a look at what M's got. Okay, well, that's good. How'd you make out with slide 9?
I had that view from
Stairs, 1.9.
I wasn't going in the direction. Like, so what I was thinking was, since it's a circle, just a smaller circle, the bigger circle, why I think a smaller triangle, and the bigger triangle, so I like the same angles. And if I didn't really.
So all
Wait, no, wait. No, if it was a triangle, I was about to say the base would be, or the height of it would be.
So is this nice off?
Alright, hey everybody, get up on your feet and move to the center. Okay, so I'm looking to just uncover some strategies like we had before, and let me borrow your eraser real quick again. See what you guys come up with. So I'm just gonna make room since it's hard to write this word right now. So in general, here's where we're headed, everybody. If I told you I have a polygon with any number of sides whatsoever, the goal would be to say, you know what, I think I have a strategy that would work. So, I'm going to throw this on the real quick. Thanks, Marissa. Okay. I was trying to get away with this, not doing this, but. All right, let's zoom out. What do these two pictures have in common? Like, what's the common strategy that you see being used there? All right, making triangles. Okay, and then what are all these triangles, like, what's the strategy for making the triangles? Because there's lots of ways I can make triangles in that way. So we're using radii, right? We're using the radius to make the triangles. Okay, and then I'm going to ask some questions that are really important, and you might think they seem like not necessary to ask, but I'm going to ask them anyway, just to make sure everybody's brain is like absorbing the same ideas. What do you know? What's the benefit? What's the benefit of breaking this guy up into 4 triangles?
But you can use the radius to solve for like the podium angles.
All right, so you get the angles and stuff. You can use the radius to get
the perimeter, okay? All right. So, we're using the triangles to get the area of the square. Here, you're not finding the area of a hexagon here, really. Honestly, you're finding the area of a triangle, correct?
Yep.
You following me? So, and they're on the verge of figuring this out, so I think it's fine. But I'm just trying to get the strategy out there. All right. What other strategies are coming into play? So once you take the polygon and you break it up into triangles, do you have a strategy? Okay, then the next thing we do, once we break it up into triangle, the next thing we do is this. Do you have this that you do? You don't have to tell me what it is, but do you have like what your next step is? I broke this up into triangles, so I need to figure this out, and then this lets me find the next thing, and we can piece it all together. That's the idea we're going for. Are you hearing what I'm saying?
Yes.
Okay, so with the amount of time that we have left, I need you guys to strategize, and you have choices here. I've had people either in writing, or you can create a video, or whatever, but your goal is to strategize and come up with like a written or recorded strategy for how you can solve it for any number of sides, okay? I'm about to hand out a rubric that goes with that. So let me clarify, because I know that at this point it probably doesn't seem very clear what I'm asking you to do.
It seems like I'm reading the same
Okay, so on slide 8, okay, it's asked you to generalize the strategy. You're doing this as a group. It has the directions there. You can either, again, you can write it or you can video it, but it has to be clear. It's not just get her done and not get her done well, right? I have a rubric that accompanies it to get full credit. You know, these criteria need to be met. We're not going to have time to finish this perfectly in the time that's allotted right now. So from now till 11:16, just brainstorm, you know, what you want to say, maybe document it on a paper or whatever, if you're going to say it, record it, or you're going to write it. I will give you time tomorrow to like put a final draft version together for your group. But everybody needs to collaborate towards this, okay? Questions? Okay, so I always end up at the end as rushed, and the end's the most important part. So I'm going to go over.
They're 16 years, right? And it goes, depending on the sport.
Every time you add a side, you add one piece.
You add one piece, so it's 5.
So should we start, so separate the shapes? Yeah, that's a whole nother lesson. That's 3 or 4 people, so that's good. We're gonna have group roles. So if there's a group that only has 3 people in it, somebody's gonna have to do more than one role. Is everything all right, Lex? Okay.
I like your haircut. But I don't know.
You got a haircut?
No, but I like the way her hair is.
That's good to know. Okay, so let's talk about the roles. I'm sure that you've all been in group roles before, and I'm not even gonna lie to you. Like, I'm not when I go somewhere and I get randomly grouped with strangers and then we have to assume roles, I'm like, oh, this is a group thing. But this is really, there's a purpose to it. It's meant to create intergroup dependency, like where you need each other. You need each other, okay? So if you only have 3 people in your group, somebody's gonna have to do double duty. You're gonna have to decide rather quickly who's doing which role. Okay, so the recorder, as it says here, that's the person who speaks for your group. So if I'm talking to your group, the reporter will answer. If another person comes over and speaks to your group, the reporter will talk for your group. So the reporter needs to know what your group like strategies are. What are you doing? You can't, I've seen it happen already today where somebody goes over to the group and says, who's your reporter? And then, how did you get that number? I don't know where that number came. Well, then obviously your group's malfunctioning a little bit, okay? So we don't want that, and it's not, okay. All right, the recorder, that's who's the person who's going to be typing into the computer for you guys. But again, you need to know you need to agree with what they're writing, right? What if they write a bunch of crap and then you all get a bad grade and you're like, well, what? That's not my fault, it's the reporter's fault. Well, no, you need to all agree on what's going to get written, how it's going to get written, whatever. Okay? All right, the facilitator, I think it was like the parent of the group. So you have to be a rather mature person to be a facilitator because not only do you have to be sort of like firm and make sure everybody's on task, but you also have to be nurturing and make sure that nobody falls behind and that everybody's, feeling good about what you're doing. Okay, so that's what the facilitator does. And then the questioner, they're the only ones allowed to ask questions of someone other than in your group. Obviously, in your group, you can ask each other as many questions as you want. But let's say, Nana's group is like hopelessly stuck there. Like they're on the verge of a breakthrough, but they're just like, what? And then, so their questioner could go over and ask another group a question. You follow what I'm saying? All right, if you want to ask me questions, they have to be like just clarifying. I want very desperately for all the big ideas to come out of you guys. Because I believe that much in you. I believe that you have great ideas inside of you. So when you feel stuck, I'm telling you, dig deep, something will come out. And then out of this whole group of people, every idea that needs to come out will come out. It'll happen. I've done this enough times. It'll happen. And, and as big ideas do get discovered, we'll share out like probably 3 or 4 times during the course of the day to say like, look at some of the things that are happening. Okay, right now decide on your roles, okay? And then
Nose goes.
You right in
Go ahead. I like this different.
But it's mine. It's not anymore.
I'll be the
It's really mine.
he bought it with his own
It's mine.
We'll get it back for you.
Is that it? Yes, right?
Okay.
Of a radius is 1.
Okay, once you decide on your group roles, I want you guys to, again, make sure everybody can see the computer, and I need you to go and work on slide 2.
Is it
I wish I had my marker.
I think
Can we just do it? Is that a radius one?
Yo, like it's definitely.
Okay, so I'll answer that. The biggest idea is crushing the biggest size.
This is just.
I think we're getting it. We're getting it.
I want to like stop having all the sizes.
So it's 3.1 is supposed to be pi.
Yeah, but
I guess it's not good.
There's the
Yeah, so do exercise.
Because like 0.8 to
square equals 2. You got 3. I got 2.14.
Yeah, I did like that.
Oh wait, I minus. Y'all are right. Y'all are right.
So, what am I doing?
So it's an equilateral, right? So all the sides are going to be equal. So once we find one,
No, it was that. No, it was that. Yes.
Wait, because like the radius one, they can hear here. If this, okay, so, or no,
You guys know what the definition of a radius is?
The angle of the definition of the radius.
Yeah, obviously.
So what's the
So use the angles to find out.
From where to where?
With the line
to where, yes. So the edge, so it could be anywhere on the edge, right? Left or right.
The only thing I'm thinking of is trying to
Right, area, that's very so, that's obviously part of it, and that's your
This is.
once you realize how that,
The whole thing is.
that's when it all comes out.
Yeah.
Well, I say ladder time.
Do you go into the sides or each side or
I get my work ready.
We're confused.
So don't we need to find out if we find one?
So, let me ask a question to you guys. Does everybody know what a radius is?
Yeah.
Okay, so I'm going to ask somebody to give me your definition, anybody, give me your definition of a radius. Half the diameter, okay?
The diameter splits the circle in half.
Okay, diameter splits the circle in half. Okay, what,
1 point to 1.
from what point to what point? What point has to be included on a radius?
Center.
The center of the circle. Okay, so if you start at the center of the circle, where would you end? Like if you start a line on the center of the circle, where would that line have to end to be a radius? On the circle, right? Okay, so I don't want to be too overly helpful, but I want to just sort of nudge you. So a radius can go from the center to any point, anywhere on the circle, correct?
Correct.
And we know that that is 1. So you can go from the center to any point on the circle. So just,
Yeah, that's what I was gonna start doing. And I was like, this is more. This is collaborative, so I don't know.
I don't know. I thought I knew it, but we don't have time.
What do you do? You have what side of it?
I give it to you, you have it.
And we find the radius.
And then if we need to do diameter, then diameter is to. Things like that. It's something like, yeah, it's something.
What were you saying?
Because it's
Perimeter areas.
I think the triangle is just to help you out. And they're even more you can make, if you like, put a plan in the middle.
So these are times the size.
Yeah.
Why don't you take a picture?
Well, you can go to Adler, you can do the radius there.
That's
You can go to any point you want.
Oh, wait, that's 1.7.
So,
No, like, you got some.
So it's like what? So that's 60.
This is 30.
Where's 1 coming from?
The 1/2.
So can we do? Wait,
That's because that's the radius.
So we have the radius.
From where to where?
Triangle right here.
Yeah, it's base.
that's the middle, right? That's the middle of the whole circle.
It'd be better if it was the color.
No, like I'm saying, like
There, that's
this triangle. So like if I find this, I can.
Up here
What?
You don't know how long this is.
60. No, but 60
So then this is another
times
triangle.
half is
Yeah, that's what I'm saying. Facial shiny.
no 30.
If this is the center, then
Just 30.
then
30
this
and 30.
is 1, this is 1.
Oh, sorry.
Okay, are these right by anyone?
That just makes sense.
I actually remember certified.
I just know why.
So say you run this line all the way down. So you say from here, this center to here.
Is he at 30?
Here to here. So we got, well, this is the height of the building, we got this line from here to here. So we got two sides.
I'm trying to, fuel some.
There's
Wait,
some
can you-
here.
We're trying to figure out.
Yeah, but I'm saying we have an angle, a side.
Wait,
So you can do all, you can do
All right, deep rough draft.
Yeah, I know, I remember, right? So add that again. So draw the line, connect the other line there.
Now you have the height of the
I'm doing
post.
this by myself. Nobody listens to me.
You have the height of the whole triangle, we don't have the height, we have the height of the whole circle, we don't have the
I
height.
thought we had to find units and square units, but then I realized it's just like
So,
2 square units or 1.6.
Oh, okay, so I'm not going to look for it.
It's pretty much cutting the triangle in half.
But can't you just do like this?
6.
I just figured out how to do
I'm gonna tell you, like, in 30 seconds, I'm gonna call us together, just a rough draft talk, guys. It's better not in here.
Cause you just did. You just did. So 30, 30, and then down to 30.
We just put this in half.
Yeah. And then I did, this is one, right?
If everything's at 30, yeah, everything's at 30.
So we know that this is 30.
Oh, you did this side? I was gonna do this. I was gonna do this one, because if you did this one, you can get the side.
Alright, let's just look at the pictures that I have up here. That, again, we're rough draft, we're not making any big, finding any answers right now, but started out with just a triangle inside the circle, and the radius is 1. So generally speaking, my experience has been that people don't really know what to do with that 1. How's that, like, so anybody care to feel like they could somehow speak to either one of these pictures? Why are these pictures useful? You got an idea, Lex?
Like, if you take the radius of set, you can put it at any point in the circle, right? So like, if you just put a line across the whole circle, you would times that, it's going to equal 2.
If I put it across the whole circle, it would be 2. Okay, but and this is important too, because this is a common misconception. I want to make sure everybody's hearing this. For it to be 2, like if you drew a line that was 2, where would that line would have to be 2 radii, correct? 2 radii. So it would have to have a center. It has to go through the center. You said it. You follow what I'm saying? So you have to go from the center to any point on the circle. So, for example, this is Claudius. So from A all the way down to here, that whole thing is 2. Because 1 and 1 and 1 is 2. Okay? It has to go through the center. So they have 2 radii. All right. I'm just trying to fuel some thoughts here. Why would drawing these lines in where they're drawn be helpful?
Because we can solve like for the other side and move away around. Like that's why I'm doing.
All right, so Arian, can you, without like giving away like specifically, just like in general terms, what are your strategy? Could you come up with like maybe points like, once I know this, I'm going to use this to do whatever? You know what I'm saying.
Yeah. Okay, so like this one, well, we can use the 90, right? Like you're not really, okay. So I'm looking for this side first. So I did 1 over the sine of 90 equals x over the sine of 60. And so that helps me find this side. Then I found this side, which is also the same side of this triangle. And then like I can just move my way around. So like if this is 30 and this is 30, then this is 120. and then we have to figure out, because we can't use like Sokotoa because it's not a 90-degree angle, on how to move around and find this side, and then, yeah.
All right, what do you guys think? Does anybody have any questions for Ariane? You might need to, it's like, we just need to grapple with this some more ourselves. Okay, that's her strategy, your strategy can be completely different. My last class said 4 different ways this was done. All right, I need you guys to know that the energy that you invest in this first problem is gonna pay off big time. So I'm just going around and see how you guys are doing.
So she said that this would be one. If you're going like this all day. Nobody's gonna see it.
Hey, I got it.
All right.
This is 2.
Oriana, do you want to share it?
Yeah, no, seriously.
Am I allowed to? Miss Wilson, am I allowed to share?
Mine is 2.
In a moment you can share it, I promise. Okay, so where are you getting these numbers from?
Wait, so I did, wait, what did I do for perimeter? So perimeter I just added up, right? So 1.73 times here.
We're trying to find the side. And red sign, and then we divide it.
And then,
We do it in
oh
red
wait,
sign.
we gotta find the height.
Divide up.
Okay, so if you would,
Oh, yeah. I'll
we
be
just signed
forgetting.
30, so inverse. We don't inverse sign both of them.
Yeah, no, you don't reverse them.
Okay.
We didn't reverse.
Okay.
Oh, you wrote, oh, I was in an angle, that's why. We did sign up for one to find this and this over. And then we got to
Alright.
What was I about to do?
Just make my way around and see before we start.
I'll be, I forget. I can do the sign, I can do sign
Okay,
too.
where's the radius gonna
So I
come into play here?
can.
So you know how big that is, right? Do you see any other radii in your picture?
Oh, here.
Alright.
I think I found.
You don't lost, huh?
Because I remember what happened.
Yeah, that's what happened in the text. I heard that.
Did you get 1.4? You got 1.4 to 1.5.
I don't.
So how did this? You don't.
How are we doing over here?
So it, yeah.
What are you trying to get? Like in this picture, what do you want to know? What do you want to test this out for? So you got, let's say you've got 1.73 AC, 1.2 right? So that's helpful. If I'm the
I already,
right? And then you're area.
well, I already know what the contrast is, and I already found the area.
Well, with her, well, yes, I said 1.3 for area, but I said to go 2 decimals.
Yeah, there's so many of them done that, so I just think you guys are like, just,
I don't know if it's
what would be useful? How can I get it?
Could we get it?
What would be nice to have?
Yo, wait, like, I'm not saying
It's so weird.
I know, I get the letter, but like, how do you do it? Like,
So you take any, try to find the side. And then you this side, and then you just go. So we didn't have it, we didn't have it.
And what would Sofitel give you in this picture? What would you be stopping for?
We saw this for this one, and then since you cut this in half, and you think it's the same angle, yeah, this other side by just.
Okay, make sure everybody's here. Wait, or, you want to share something? Or you want to just,
So, like, so that, so to be SoCoToa,
Well, somebody
to
else can
figure out
record, you know what, I'm like.
this side right
Who's
here.
the recorder? Who's the recorder?
Let's say it goes.
But if I explained it, they don't understand it.
Why not? Just need to practice so they can.
Cosine and
She did that.
Well, how did you do it the same
trying to
way?
figure out this.
But no, because I didn't find this.
Yeah, this side, because it's.
So this was just better results. I
Just add it,
add what
and
was
then you find that, since everything's the same angle, then you just.
Yeah, just quick, like, I started.
It's time to share it.
I found this because I knew that if this is added up, like you got 1.7.
Yeah, but I'm saying, but I didn't have to add it because I just got the whole side. You know what I'm saying?
Yeah, explain them all.
I can find all the fun.
Yes, sir.
I understand the other.
I didn't hear what you were on. I just used to.
I can't, like, I just can't.
All right, Arian's gonna share her strategy, or her group's gonna, somebody from her group is gonna share her strategy. And again, if you did it a different way, don't like throw out your idea. We can add on. If it doesn't make sense, you have the opportunity to ask her or them clarifying questions. So whoever wants to speak for your group can go.
Or I won't do this. Do I got it? I get
So
it.
it's pointing.
Whatever makes it best for you.
Okay, so like I was saying earlier, you could do law of sines because we had a side and an angle. So I used 1 over the sine of 90, and then I solved for this side because once again I said like this side is shared between both triangles, and I got 0.5, and then I used law of sines again to find this side, and I knew that these two triangles are exactly alike. So I did, but I just double checked my work to make sure. I got 0.866 on this point and then 0.866 for this point. So I got 1.73. Then I checked all my partners and they got 1.73. And since it's an equilateral, it's 1.73 all the way around. So you can use that for perimeter. And we got 5.2. And then for to find the height, what did you do? Oh, he did it a little different from me, but I forgot about the smaller triangle, and I just used the bigger triangle, and then I did law of sines again. And I did 1.73 over the sine of 90, and then I did x over the sine of 60, and then I got 1.3.
1.5.
Oh, 1.5, and then the area is 0.5 times based on height, so 0.5 times 1.73 times 1.5.
What questions do you guys have? Is there anything, honestly, it's fine. Where did I come from again?
Oh, yeah,
You
y'all
have
got questions? No?
All right, let me point something out if you don't mind. So you had already solved that this was 0.5, right?
Mm-hmm.
And you already knew this was 1.
Oh, I could have added that.
Oh, 1.5.
I didn't even see that, actually.
Okay, so that's further clarifying that, yeah, you know your answers are correct. But is anybody going down a different route or like using anything other than the law of sines at this point?
So how would they get
All right, Matt, you were saying you were gonna, similar idea in that you were trying to find the side lengths, but you weren't using law of sines. What were you using?
SoCoToa,
Okay, so we could use SoCoToa. Why can we use SoCoToa here?
because it's a right triangle.
Okay?
I don't know why people forget like something like
Because of law of signs.
yeah, like I
As soon as
just
I did that.
I just can't. I was gonna
It'll
say
come
like,
back, trust me. Tomorrow it'll be back. All right, so you guys are having some good conversations back there. Did you have anything you want to add on to this or questions that you have about something you're trying, or are you guys feeling all right? No? Do you have a question?
I'm just like I'm trying to sound dumb, but like from the radius, right, or the point, the middle point of the circle, out to a point on the triangle or the circle. Like, how is that one? Like, it's just always one?
Yeah, so that's how we started the whole problem off.
Yeah, to find the long side.
See, everybody just takes.
Alright, so if everybody, I don't want to be the one talking too much, I just am trying to highlight some ideas that you guys are saying. But assume there's a circle around this guy. So when we draw in these sides, like you guys did in this picture here, we draw in these sides, are we okay to assume that each one of these is a radii? She has it 1, 1, 1. I want to make sure everybody is feeling that. So, because it's from the center to any point on the circle. That's the definition of a radius, from the center to any point on the circle. So, one of the things that I saw is so common too, it happens every time I do this. When I said the radius is 1, people want to draw vertical and horizontal lines, right? But I'm trying to point out, like, you can draw them any direction you want, any direction you need. So it's helpful to draw them in this way. All right, so I'm going to try to spur some extra thoughts without giving away everything. And I'm not an artist, but these are all 1, okay? We knew that this was 60, 60, 60, so now each of these is going to split, right? 30, 30, 30, 30. Okay. All right. What about these central angles? How big are those?
120.
That's how I do it.
All right. So that's how you did it, Jay Sean. You did it. You found the 120 first.
Yeah, and I went to the bigger side. Except I had to split it in half.
Good. Can you share with everybody how you found the 120 first? Do you want your marker? What's your marker?
Say because of me. Because I told you.
Hey, yeah, Orion gave me some insight
Thank
on that, but
Okay.
after I did that, I did a lot of signs.
But how did you know it was 120?
180
Well-
was Wilson?
Oh, okay. I was just, okay. Let me make sure. Okay. So go ahead. Go from there.
So this is X, and then, so you have 1 over sine 30.
Wait, I have a question.
All right, so stand back, everybody's sitting over here and go, oh, I did not think of that.
Wait, but I thought you can do that if it's not a 90.
Sure. Right, law of science is actually, that's number 1 use for law of science is when it's not a right triangle.
So,
Right, and you do that, you get X is 1.742 or whatever. All right, one last idea. So you didn't necessarily need to split it up into right triangles, all right? Let me borrow this back again. I'm gonna go back and draw this one last time. What do you know? Oh, I don't know, I'm reading it too much. Okay, what would happen if I just found the area of this piece of the triangle? What if I just found the area of this little guy? Would that work? You follow what I'm saying? Would that work? I'm not an artist, like I said, but if this is perfectly symmetric, these triangles all have the same angles and the same side lengths, so they're the same triangle, right? Okay. Last thing I'm going to say is this. Watch this now. It's probably not the last thing I'm going to say. It's a lot. It's a lot. All right, so this is 120, and this is 1, and this is 1. Come up with another way that we could come up with that.
I was about to say, I know she never threw this burger.
I don't know where that is.
You want us to do it?
All right, no, what I'm just trying to get some more ideas flowing. You see what else we could do there, right?
Yeah.
Okay. All right, we'll just do that. We're good. All right, so we're going to, we know now that we can use the radii to help us find extra information. So that's the only reason of putting it in a circle is because the radii will be useful. Okay, I'm going to ask you guys to go on and quickly look at
at slides 3, 4, and 5, don't spend like ridiculous amount of time. So make it so everybody can see it. Have a quick conversation, 3 minutes
Are we
maybe.
doing it or just?
You just, it's a question that you're having a conversation. There's no math to that. All right, priorities.
It was how would
It's just the shape.
Inside with, they're all hard.
Oh, so if the polygons had more on our sides, what would happen?
Wait, this whole size?
What if it said if you had a triangle, it had 5 sides or 6 sides or 8 sides?
Let's say if I was but this whole thing is still the same. How do we know we're doing the area of that, right? If I was to like the circle, and this individual
She's asking you to make a conjecture.
Like, what do you think would happen?
Yes, the same is like 1, right? This is further.
Like, if you're using the outer part.
So you're saying that,
With these 3 numbers that are.
what do you think it would, you think the perimeter wouldn't
But like
change
the
the area?
circle 2 is. It's like
Outside out, so like now it's the area now. And one shape and then
So this is a cross shape.
outside is the
The area is bigger.
You know, the area right now, we'll end up doing some
The
math.
space that is taken up is.
I didn't think, but I have no idea.
Okay. So you might at this point not know, okay, a polygon is just a shape that has many sides. Poly means many. So we start out with a triangle, and the question just said, what if you had 4 sides, 5 sides, 6 sides? What if you had 28 sides? Do you think that it would take up more area? Do you think the perimeter would get bigger? Do you think they'd stay the same? Do you think they'd get smaller? I mean, what do you think? So just take it, you know, have a little conversation about that.
No, like, I feel like, is it within a triangle or within a circle?
Within the circle.
Within a circle.
Oh, then it would change it.
Yeah. Within the
Remember just putting a polygon with more sides in it.
So it increases as the shape changes. Like if we add more sides, we change. Adding more perimeter area.
But it's,
Alright, and then just write down, you can change your mind later, you can discover something later and feel like, you know what, no. Inscribed means all the vertices are on the circle. Alright, so you know, once you get your little answer typed in on slide 4, on slide 5 is just a polygon generator, so n is the number of sides. So there's one with, you know, that's the smallest one we could have, that's the one we just did. Right? And it keeps going. I limited it to 15, just because after that, you know, it wasn't as meaningful to look at it anymore. Stop seeing the difference. So maybe this helps you answer some of your questions. Okay?
Feels like a hypnotized somebody.
All right, so I'm going to ask you guys to, because I've learned something from my last class time-wise, I'm going to ask you to, on the paper that I just gave you guys, try either a 5-sided or a 6-sided figure. The radius is still 1. And see if you can come up with the area and the perimeter. Okay, so use the pentagon or the hexagon. And if you get one done, go try the next, you know, but start with either the pentagon or the hexagon.
Well, I'll do the hexagon.
Right, wait, so this is one, or it has to be a plan.
So you guys come up with a strategy. So, what is it?
It's like the restaurant.
Is that slide 4 that you're looking at?
It's just like, what did you guys come up with a thing like, oh, we think it's gonna get bigger or whatever?
A to B.
Right.
Wait, so as you
That
guys
one's
were
right,
saying,
No, it's just like calculator.
It's not a north.
let's say divide this in half. What is the degree of circle,
So
right?
I might ask if this is going to be showing that.
This is one. Oh, I'm going some, this one, so I'm going some. This is one. Period.
Oh, that's why I gave it to you on paper. If you need more than one paper, I have extra papers.
No, that.
Yeah, I'm about to do it on paper.
Yeah, do you want a ruler? Would that make you happier?
No, I'm not.
Anybody want a ruler?
Oh, actually, Miss Wilson.
I don't want you to be afraid to draw.
With the 360, is what
Well, okay, I can have one.
You want a ruler?
that's all. I used to that.
I mean, but I'm only in, I want, right? Because the radius is still one.
So 540 divided by 5.
He has an idea, sir.
I don't, it's not 360, this is, how many, however many
Anybody
degrees,
want a ruler? You want a ruler?
and you divide it by how many sides. This was, yeah, so that's 6. That's an hexagon. So that's 6. So how many do you guys decide all of divided by how many sides?
How do you know how many So, why did you do
It
that?
wasn't 72. Well, I didn't think it was. But like if you, because
Oh, no,
you
I'm
just
just
say
making all.
540, it's 540 degrees.
I did it. I freaking did it.
Wait, are these equal?
So this is.
You're asking all the right questions. I feel like you need to listen to each other's questions. Okay, Ariane's asking some really good questions.
Wait, these are equal atoms.
Yeah,
that I
well,
just-
they're not, they're isosceles.
Doesn't do five.
Yeah,
So this side is one, so this side is one,
You can't
this
do
side is
square.
one, so this side is one.
Oh, so you have to-
They're all
So this
isosceles.
is one too.
Maybe,
Yeah, the radius.
we'd have to figure it out.
I
You
don't got
got,
time.
for this to be one, you have to say this angle.
How can you figure out the angles, I guess, is that's where you are.
Remember the triangle, like when we
But you
go-
don't have to, you don't have to decide. You need two sides of angle out.
One triangle, I
No,
think
it's
it's
be one.
side, it's not equal.
How math. I said like, what I said was like 360 divided by 5.
doing the Pentagon?
72. So like this angle is 70.
Well, that's how you,
Because if you drew a circle,
there's something center or can.
and you
Out, right?
25,
So
it's
center, because the, so you have this line, it's gonna be right angles on it already.
So I look at 60 divided by 6.
I don't mind people going back and doing square
So
areas.
this is
So
last
this
time.
is 6. And then,
Well, now you can say it is.
alright, but I was still right.
Yeah, but you didn't have no evidence. I got it.
Technically, I did have.
How will you approve it?
360 divided by 6.
Yeah, that's what I did.
So why are you doing 360 each one?
Because you can say it's dividing
Because-
circles into
yes.
360 degrees to 6 circles.
Okay, so then what would you do on a Pentagon?
That is different. So this is.
Okay.
Okay. I wasn't sure.
Okay. Come here, are you following all that? Who's your facilitator? Aren't you?
No, because.
He's the facilitator.
Yeah, area and perimeter.
So,
I think they're cool out of.
1 times 6.
I would have one in my hair, guys.
What is that?
But sausage has two sides the same, one side is different.
That's good.
Yeah.
So
Even numbers on sides.
So this.
6
No, because what we want to show.
You know,
Wait, I know.
you know what?
All the sides are one and all my intersections.
Okay, so.
No, so I'm saying like, if I'm looking for area, if I'm looking for perimeter, I can do 1 times 6.
Yeah, that's why I said the perimeter.
So perimeter is equals 6, and then
For sure, so that's that thing on that, for sure.
You can find it. So it'd be, maybe we just had it.
It's gonna be like just saying
one, and this is one.
Oh,
Base times height. The height is two. Perfect. Yes, it is, because this is one and this is one.
It's not the height of a single triangle.
You just wrote down. Yeah.
Now you're not gonna forget it, you're gonna see it. And you're gonna be 16. I got it too rough.
Alright, now I got it.
Her grandparents signed, basically, on a circle. What I know when you're
Oh, you have the one? I know, I don't know. I thought you said one. Now we need to find out the size. What? So 3? So the perimeter's 3.
How you doing?
I need help.
And how do you use that one?
No, they do it. I know what I'm doing. I think it's oh, there's no side. You're right. She's right.
I got a perimeter of 6.
Which one?
6. So how shape 3.
You guys know?
So make sure. I thought I picked the hard question. Do you understand?
Why you do the line?
Yes. Yes.
Mine was 0.86.
So then, what are you trying to do next?
I'm talking about your side, you do all crisp and one and all this.
So which one switch?
Okay.
So take my hands
I'm not expecting
I don't know what the, I do know what the, how to find areas.
And I'm
That's a good question.
is that?
Oh, we're going to break for me. How do you do it?
It's almost like A squared plus B squared minus.
So
I just jump on my feet, right?
B squared minus 1. You get what I'm saying?
So you did that and you measured 1.2. Close to it?
So can I just work on my own?
I would call that one.
And don't consistently go into the gym.
Yeah, I would do the rest of it. Well, no, just do 1 point, just go good, go this, boom, boom, boom.
So I'm thinking number 2 and then sausage.
8.
Oh, yeah, you're trying to see my.
Just go by the.
Okay.
It's bad if I do it like this.
I just think because it's a small number, it was like 1,005. What matters, but 5 you can get counted. Alright,
Where's the open?
They're both ones, the last one.
Just limit the day.
no, I'm not.
Not you, Miss Beans.
So now you guys need to brainstorm a strategy.
Yeah, I would put that.
What if we find the area of one triangle and then multiply by 5?
That's your partner, what do you think about that?
There's multiple.
Remember how you were stuck and you didn't know, and then I didn't even say anything, and
You have to do log sign.
pursue that, Ms. Burnham, pursue that. But make sure you're comfortable.
Do you think that we should? I would do log sign. 1.38.
Log sign is 1.4.
I would do 1.38.
Well, what's this side? This is equilateral.
What's up, dogs?
We don't know how many angles though. I have a question.
You're only talking about.
Up here. I didn't have video to pull my hands up all day.
Sides of each triangle.
Okay.
Yeah, from this point to this.
So what would you like to know that you should
Me.
What piece of information would be useful for you being successful in doing this? Is there something? Okay, so go in your questionnaire, go off to another page and say, how much
You get 4.8
finding angles? So go with share one of these, like,
You're supposed to confirm.
just come up with an idea, but it wasn't really similar. Here's my dilemma. I was like, can you share it? Cosine C. Well, you're not one of my just draw cosine C, that's C at the end, that's an angle. C in the beginning, that's the side, it goes with that angle. C in the beginning, now we're all on the side. Right, so if you knew one, you could find the other, right?
And they don't, these are not,
And right now, you don't know.
these are not equal out on the So if I
It's not good. Right, for sure we know they're isosceles, for sure we know at least two of the sides are the same. We need to find out what that third side is to know for sure. So if this gets an idea. It's like little. So now you know that. What's the shape if you go all the way? Okay. So draw a circle big enough to write numbers. Not that big. Right, yeah. You know how many degrees the circle has? So now how many are coming first?
I think we start on
Now they know what to do. And if each of those little lines is one, and you can, and you have five, you can find one of these.
you draw five. I love you, Madeline.
Wait, but I still have a question. Okay, I got it. I got it. How do we do it? Yeah, we were doing it wrong. So this is
Oh, no, that's not one.
No, like what?
Do you have any
So-
angles?
I put a dot here, right? And I made a circle, and I do a circle. Many. So you did 360 divided by how many sides you have, so here is 5, so you did 360 divided by 5.
No, I'm not talking about.
So on each of these little things
Oh, I don't know.
is 72. So this is 1, this is 1, this is 1.
I got for the sides, because you need to be precise.
So you have 72, you have each side, so you could do cosine sine.
What about
And each of these are the same.
That's what she's doing right now, so she had
So I'll take that.
We learned it last year. Like, I remember, ninth grade. Last year,
Only reason I was there.
No, wait, what am I doing? Like, I feel like 1 point go back to Coach. Oh, 1 point. Because. 8.
One, 7, 6.
So like, I would want to practice, is it
That's what she's doing.
Yes, that's supposed to be comfortable.
Okay, but so while you, well, Lexi's at the bathroom, she missed some.
So, this.
Oh, you know that one too.
I didn't get 1.7.
So the 360, you talking about the angle?
Yeah, a little bit more precise, but it's like, it's 1.7.
It's each side, right?
That's a 1.2.
Yeah.
Remember you're saying.
I can see that.
I would use 0.58.
I'm about
Okay,
to
so your question is, so you see how this 45? This 45.
So what's your strategy for finding
Yeah.
this whole thing?
No, we just found the angle.
Oh,
See?
area of the whole thing.
Yeah, what are you gonna
Finding
cut
the
this in
area
half.
of one of these triangles and then multiplying it by 5.
Does that make sense? Yeah, I'll do that.
Or you could have just did 25, 100 minus 45, and then divided that by 2. This angle, this.
No, I'm getting at it.
I can see that's the thing, I should be working.
What are we doing over here?
Angle. Oh, that's cool.
What did you get for your side?
So, right, you want to find these two inches, right?
Not your sides, angles, your ankles.
Trying to have 180, and this is isometric. So these two angles.
Yeah.
Oh, no, no, hold on.
So you
Oh,
do
yeah.
45, 180 minus 45.
You could have done either, so that.
And then 135 and you divide it by 2. Because these two sides are the same.
809.
So isometric has two sides that are same.
What did you get for your
Well, I All right, that's the hexagon. I need a pentagon one.
Base is, yeah.
I-
Well, do one.
That's all right.
176.
How many went over here, guys?
176.
So we're at a pentagon.
Yeah.
That's
the area.
So we should do for area. I just found that the area of one triangle times by.
Oh, I thought.
Not a triangle.
Alright, so
45, 25, 90.
if you're like in the middle of a calculation, finish that up, then we're just gonna share out some general strategies that are presenting themselves. And then I'll tell you how this thing's gonna culminate.
Yeah. What you gonna do?
Okay, but I don't wanna stop you.
I'll get it.
I mean, so maybe got the area. Okay, so how did you get to 5?
And broad triangles.
Or you don't even have to do that. Just
So
do it.
how did you get all the sides?
The 1.176.
Triangle has two sides of the same base and the same.
Now we have to do the 6 sides.
Oh,
By adding
I like
by
doing
doing
this.
1.176.
Sort of.
But I mean, you don't have to split it in half, like, I'm just telling you, do love,
There's
love.
5 sides.
Wow.
So that's how I did it.
You have 3 angles and you have 2 sides. So pairs don't match up.
We basically did that one.
So you have 1 and 1, and then you.
Are we gonna share this
seven,
sooner? Can I start the
five.
next one?
You can start the next
One
one. I
over
just,
6
they're all in a conversation right now.
X over sine of 45. You know what I'm saying?
67.5.
Okay, and what did this do?
All right, was that helpful going over and questioning your people? So then you're able to, yeah.
So can we use it for all of them?
What
did I say?
Can I do my work?
You right.
Can I do my
I
work?
was just trying to be a helpful person, you know.
Thanks for being a helpful person. So, all right, push the pause button for a second. First off, I want to tell you that the conversations are good, and I really do hope that your groups are being as good as they appear to be being. I hope you're not faking it, because, you know, like faking like you're a good group, because you all seem like you're doing good group work. You know, hope you're not posers. Okay, secondly, I just want to uncover some strategies. So, without, like, me stating the obvious, this is going to be obvious, everybody went ahead and split their shapes into triangles. Okay? And everybody used radii to do that.
Okay, so that's good, because that's the only piece of information we really knew, was the radius. All right, and then after that, some people got stuck for a little while. So Sophia, can you share with us, like, what did you learn by going and visiting another group? I'll just use this picture, but can you share with us something that you learned by visiting another group that you found helpful?
Well, Maddie took me, like, she taught me a trick, like, I did the middle, so, like, I know that the circle has to equal 360 degrees. So I just divided them by the sides, and I got 72 for all of them.
Does that make sense to everybody? So that wasn't maybe immediately obvious to everybody right off the bat. That's useful as all heck though, right? Okay. So if we know that that's 72 degrees, now we have options, things that we can do with that. So, how would you go about finding the perimeter at this point? Once you know that the central angle is 72 degrees, how do we go ahead and find the perimeter? We have a plan, does everybody have a plan?
Yeah.
Okay, so you can figure that out. I won't, people are, or don't want to be asked questions that they think are too easy at this point. But remember, half an hour ago, we thought it was a hard question, and now all of a sudden it's an easy question, so that's a good thing. I'm trying to really be careful with how I ask these questions. So, Maddie, can you share with us how would you find the area of a pentagon?
Well, I knew that once you broke it up into like the little triangles, which you should be able to see, you can see that there's 5 of them. So I wanted to find the area of 1 because I know the formula to find the area of 1 triangle. So once I found out, you can see that it was 0.476, and then I just multiplied that by 5 because there's 5 triangles, and that gave me 2.38.
All right, so do you understand in broad terms what her, okay? I mean, honestly, I'm gonna bet that if you Googled, you could find the area of a pentagon, but I don't know that formula. I would never remember that formula. I would totally just say, I'm gonna break that pentagon up into triangles, because on my deathbed, you can come visit me and I will remember the area of a triangle as 1/2 base sensei. I will never forget that, okay? So, we can find the area of each triangle, and you don't really need to do it 5 times, you just do it once. All right, so the goal is, and then Nana asked the question, wait a minute, can we just do that on all of these? Can we just apply the same strategy over and over and over again? If right now, I all of a sudden gave everybody a picture of a polygon with 60 sides on it, would you know what to do?
I'll be irritated.
You'd be irritated, but I would tell you, I don't think it, if you reflect on this question I'm about to ask you, to find the area or perimeter, listen to what I'm saying, people are calculating and you're doing math, and I didn't want to really squash your thought pattern, but really think about this for a second. If I gave you a polygon, let's just say 50 sides on it, I'm going to challenge you to think about this. I don't think the math would be any more than if it had 3 sides.
Because you can find just one triangle out of the triangle.
All right, say that again.
I
Why?
forget what I said.
So you find one triangle.
Oh, yeah, multiply.
And so the amount of time it takes to find one triangle is the same regardless, right? So once you find one triangle, you can find them all. But, well, I have to hit times 50 instead of times 5, so it's 1 extra keystroke. Yes, and maybe it does take 8.1 seconds longer. All right, so I'm feeling like you guys are okay. So at this point, you can finish up your calculations. You should get an area and a perimeter for 1 or 2 more, 1 or 2 polygons. If you got 1 or 2 polygons done, and with confidence, using strategies that you feel like you really possess, then you're good. I'm just going to open this all up. If you get to this point where you feel like you're ready for this, I need us to look at slide 8. Okay, so I'm just gonna talk about slide 8. You might not be ready to go there quite yet, but I just want you to be prepared. Okay, so slide 8 is gonna ask you to work with your group to communicate your strategies. And your strategies have to be able to be universally applied. Like, if you had any polygon, these are the strategies that you would use. Okay, so I give you options. You can either record your video, your group can make a video recording of what your strategies are. If you want to use the dry erase boards around the perimeter of the room or something to do it. Or you can write it up. Again, you want to write it up on the dry erase board, you want to write it on your desk. I really don't care. You have options, but you need to clearly communicate your strategy, right? There is a rubric that I'm going to use to score it. So I'm going to hand out the rubric so that you can see what I'm expecting. And by the, we got quite a bit of time. So I would think that you should be able to get something together and submit it. You only need to submit one for the whole class, but it has to be clear that everybody, I need
For the whole class or the whole group?
the whole group, sorry, the whole group. Okay. It needs to be clear to me that everybody in your group has a say in what you're doing. Okay.
I'm thinking about it and it's not.
Yeah. So,
Yeah, we need a blank copy.
see that works, let's go through a square. Although, like, the square has so many even more options, and you could spend a whole class just talking about different ways to do a square.
Easy, and you can pause it and show you.
You never made a flipgrid?
Like, here's one here.
Yes. Come on, it's good. Are you gonna do flipgrid? We're gonna try.
This is what you need to do to get excellent, like.
Can we just go step by step?
Yeah, and just say, or any number of sides of the system. Get this angle line.
Well, you can use one as an example.
Okay, well, I do not.
That's true, so.
Those numbers take away 100. And then
Alright, here's what the report looks like, so like, make sure that you can get.
Miss
10
Wilson,
questions.
why would you give us all, like, why can't we just show it to the?
You want to share one?
Alright.
Yeah, so it's straight.
I don't know, like, if I go. So then you can find an area of weight, and you know the.
you can turn the sides of
Yeah.
yeah, you give it
And then you
a
look, once you find
the points
it.
I was thinking about it,
So it evolved over time, which is good.
Alright.
Reflection.